Hello, in this video we're going to look at an example from Chapter 6 in the Lock 5 textbook, the Chapter 6 review worksheet, number 4. So psychologist Ryan and Zenner in the 1930s developed an experiment to determine if a person has ESP, extrasensory perception. So there are a bunch of cards that have one of 5 symbols. They could be any symbols, but they could be a star, a circle, 2 straight lines, 2 squiggly lines. And then you would ask a subject to correctly guess the symbol behind the card at random. And if you want a clip of a version of this that's, I think, pretty humorous, click on this link to watch a clip from the first original Ghostbusters, where they go over this type of experiment with some extra variables, as you might see. But suppose Dr. Venkman tests his own ESP by looking at 100 cards, or someone shows him the back of 100 cards, and he guesses 27 correct out of 100. So we're going to use Dr. Venkman's results, the 27 out of 100, to determine whether he has ESP. Okay. So we're going to do a hypothesis test, 99% or 1% significance level. And again, a formal hypothesis test should include the null and alternative hypothesis defining parameters. So I want to do that first. What are we doing right now? We are looking at a proportion. Dr. Venkman got 27 out of 100 right. We're going to let P equal the proportion of the cards Dr. Venkman gets right. But we have to imagine here this would be not a sample of 100 if he could get 1,000, a million, a billion cards, and how many does he get right? So it's not 27 out of 100. In fact, it might even right underneath. We have, excuse me, P hat is the 27 over 100, which gives us 0.27. So the P hat is 0.27. P would be if Dr. Venkman did this experiment many different times. Okay, but we're going to use this as one sample to test this claim. So I want to set up a hypothesis test. It's going to be a P equals. So one proportion, the proportion of cards Dr. Venkman gets right. We are going to assume that Dr. Venkman does not have extrasensory perception. So if he is just guessing at pure chance, I'm going to just put a parenthesis here. We assume Dr. Venkman does not have ESP. That is the null hypothesis. The alternative hypothesis is that Dr. Venkman does have ESP and he should get greater than 1/5. So alternative hypothesis is that Dr. Venkman does have ESP. He does have some special powers. So we've got to look at the assumptions, requirements necessary to conduct a test. So I'm going to look at our inferential statistics formula sheet, and notice we are doing a single proportion. So I'm going to use this first row. We've got the standard error, confidence interval formula, and test statistic. But I want to go to the second page of this to look at requirements. For single proportion, we need to have a sample that has at least 10 successes and 10 failures. So in this sample, there are 27 successes. That's 27 out of the 100 cards right. And then on the flip side, he got 27 right. So out of 100, he got 73 wrong. So the requirements are met. So we have at least 10 and 10 on those successes and failures. And then now I'm going to compute the test statistic. So I'm going to do this in a couple steps. Let's look at T equals, and the test statistic up here is P hat minus P over the square root of P times 1 minus P over N. that's a p hat minus p, all divided by the square root of p times 1 minus p over n. And that would equal, in this case, p hat is 0.27 minus p is 1/5, which is 0.20. And then at the bottom, I've got the square root of 0.2 times 1 minus 0.2, all divided by 100. So notice when we're doing a hypothesis test, if we look at the formula, that standard error is from the null hypothesis, that p. I'm going to plug this in my calculator. All right, I got a 1.75 as my test statistic. And from that test statistic, we could look at p-value. Oh, excuse me, I made a mistake on here. We are not using t, we're using z. Our test statistic is z for a single proportion. And now I need to get the p-value. And to do that, I'm going to look at stat key. And just to note right here, since p is greater than 1/5, this is a right tail or one-tailed test. I'm going to go to the main screen. For z, we're looking at normal. I'm going to click on right tail. And in the bottom, change this value to the test statistic of 1.75. And that gives me a p-value of 0.04. So the p-value is 0.04. All right, so then the decision on this, we're comparing this to a 1% significance. So since p-value is greater than significance, we do not reject the null hypothesis. Although Dr. Venkman did get more than 20%, he got 27%, this sample does not provide strong enough evidence to conclude that Dr. Venkman has any type of special powers. You could say he just got pretty lucky getting 7 more than he should have just by pure chance. Okay, what I'm going to do now on the same problem is create a 99% confidence interval. If we look into the formula for the confidence interval, it's a p hat plus or minus z star times p hat times 1 minus p hat over n. So I'm just going to note right here, z star for a 99% confidence interval is 2.575. All right, and the confidence interval formula is p hat plus or minus z star times the square root of p hat times 1 minus p hat over n. So if we compute that value, oops, excuse me. Okay, sorry for the distraction. So we've got a confidence interval formula. I've just rewritten it on the worksheet. And now we could fill in all the values. We get a 0.27 plus or minus 2.575 times the square root of 0.27 times 0.73, all divided by 100. So if we throw that in the calculator, we'd say we are 99% confident that Dr. Venkman guesses between, I gotta type all this in, 0.27 minus 2.575 times the square root 0.27 times 0.73 over 100. Guess is between 0.156, and if we change the minus to a plus in the formula, we get 0.384 of the cards correctly. So notice we have this confidence interval about 15-16% to 38%, and 20%, the null hypothesis up here, p equals 0.1/5, 20%, lies in this confidence interval. So once again, the confidence interval and the hypothesis agree with each other.